Afternoon, everybody. So I want to tell you a little story about why I'm here giving this talk today. And it's a little bit of a confession. So earlier this summer, I was working on a project that was adding some custom video processing for file uploads on a Rails application. And it had me looking through the source code for active storage, which is the library that Rails uses for file uploads. And while I was in there, I came across these lines of code. And I didn't know what they did. I was familiar with require, but I'd never seen require dependency before. I didn't know why they were there. I didn't know if they were part of Ruby or part of Rails. So I did, what a curious developer does in that situation. I shoved that curiosity aside because I had a task to do. Fortunately, those lines were sort of inconsequential to what I was doing, so it wasn't a big deal. But it was pretty soon after that I needed to package this code I was writing into an engine to pull into our Rails application. And while Rails gives you some boilerplate code for engines, it's still ultimately up to you where you put the engine and how you require it and some of the glue that holds the engine together. And again, I felt myself in unfamiliar territory. And I was really uncomfortable with this knowledge gap, but I needed to kind of face it head on. And I decided to cargo cult an engine, search Stack Overflow and find another solution. Of course, cargo culting is when we use an idea or code from somebody else that we don't really understand how it works or why it was used. And I've cargo culted far more often than I am comfortable admitting. But ultimately, I got this thing done. But I was feeling, kind of ashamed and embarrassed that I never actually took the time to dig in and understand how this stuff worked. I just kind of plowed through it to get the job done. And I was embarrassed because I've actually been writing Ruby applications professionally for 12 years. How can I be doing that for 12 years and not understand how to require code in a Ruby application? So my goal for today is to fill that knowledge gap that I had and that maybe some of you have as well. So before I do that, quick introduction. My name's Adam McCrea. I go by Adam Logic everywhere online, Twitter and GitHub. I work for a company called You Need a Budget, also known as YNAB. We make budgeting software to help people take control of their money, and it's amazing. I also built a Heroku add-on called Rails Autoscale that'll make your life a lot easier if you're running a Rails app on Heroku. All right, let's talk about dependencies. So in this talk, I'm using dependencies to refer to any code that we need to bring into our application. And I think of them as coming in three flavors. So first, we've got standard library code. This is things like CSV, OpenURI, Logger, things that are packaged with Ruby, but we do need to require them to be able to use them. Then we've got Ruby gems. So this is code that other folks have written. They've generously open sourced it, made it available to the world, and we want to pull it into our projects. Finally, we've got code that exists within our own projects. Obviously, for anything of size, we don't want to put all of our code in one file. We want to split it up. We want to put it into modules and subdirectories and do all that stuff, but we need to glue those files together. And every language has a way of doing this. PHP has include, Node.js has require, ES6 does the same thing with import, and of course in Ruby we have require, and requirerelative, and requiredependency, and load, and autoload, and bundler, and then of course Rails, where everything just happens magically and you don't actually have to require anything. As I dove into this stuff, I was kind of blindsided by how little I knew about a lot of the nuances and the different techniques that were available to us. And as I was learning, I kind of fit things into a mental model where we've got this matrix, and on things on the left side, these are things that are eagerly loaded. That means when we tell Ruby we need this dependency, Ruby's going to go and get that dependency and evaluate it right when we ask it to. On the right side, we've got lazy loaded dependencies. These are dependencies where we're going to tell Ruby we need a thing, but don't go get it yet. Go get it later, if you have to. And we'll see what that looks like. On the top, we've got explicit dependencies. This means we're telling Ruby exactly what we want and where to get it from. And on the bottom, we have implicit dependencies. That means our program needs to just figure out where to get things from. We're not going to tell it exactly where the files live that we need. So let's dive in and talk about the star of the show, which is require. Require is really the foundation of all these methods. And to understand it, let's take a look at some examples. The simplest thing you can do with require is requiring a standard library, like CSV. CSV comes with Ruby, but if we try to reference CSV without requiring it, we will get an error. We need to require it first. Require returns true. That means, yes, we found this thing, we've loaded it, everything's great, and now we can use CSV. If we try to require it again, require returns false. That just means we've already loaded the thing. We don't need to load it again. So it's not an error state. It's just saying nothing happened. You can require things multiple times, and it's essentially a no-op. So what is require? Require is a method. It's a method on the kernel module, along with a lot of other methods that we use a lot, like puts and raise. And because they're on kernel, that means we can call them from anywhere. And because they're just methods, that means they can be overridden, as we'll see very soon. When we pass a string like CSV to require, what it does is it looks at a global variable in Ruby called load path. Load path is an array of file system paths, and the require method is going to go through each of those file system paths in order, looking for this file this name that we've asked for. We asked for CSV, so it's going to look for a file called csv.rb and a few other file extensions too. It's going to look in each of our directories in load path. In this case, it's going to find it because the standard libraries are all in load path out of the box. But we can actually add to load path, as we'll see in a bit. So when it finds this CSV file and it loads it, it's also going to add it to another global variable called loaded features. Loaded features is something maintained by require, and it's a list of every file that require has loaded. That way, when we try to require it again, require knows not to load it again. And so once we've required CSV, csv.rb is going to be in loaded features, along with a lot of other CSV-related stuff, because csv.rb had its own requires, and it required other things as well. So that's requiring a standard library. Requiring a gem looks very similar. So MiniTest is a gem. If I've got it installed on my system, if I try to use it without requiring it, it's going to be an error. I need to require it. And once I require it, I can use it. This looks, on the surface, identical to requiring a standard library. But there is a subtle difference. If we were to look at our load path before we required MiniTest, we would see that MiniTest actually is not in our load path until we require it, and then it is in our load path. What's happening here is called gem activation. And remember we talked about how require is just a method? RubyGems overrides the require method to give us this gem activation functionality. So what happens in the RubyGems version of require? First thing it does is it checks loaded features, just like the original require method. In our case, MiniTest hadn't been loaded yet. So then it checks load path. MiniTest isn't in our load path. So it's going to just check for a matching installed gem. And I did have MiniTest installed. And at that point, it's going to add the gem's lib folder to our load path, so that when then it proceeds with the original require behavior, it'll find it in the load path, and it'll be able to load minitest.rb from the MiniTest gems lib folder. Now notice there's an asterisk next to lib there. That's because you can actually change the name of that folder in a gem spec when you author a gem. The vast majority of gems are going to use lib as their require path, and that just means that's the folder that gets added to load path when the gem gets activated. So the third thing we want to require in a project are files that's actually within our project. And here we've got a very simple file structure. We've got a main.rb and an example.rb inside of a lib directory. And what we want to do is we want to require example from main. Simple enough thing. But what's going to happen if we try to just require example, or we try to require lib example? These are both going to fail, because Remember, require is just going to go through our load path. And this particular project isn't in our load path, so it doesn't know how to find these things. So we need to take some different steps. There's some different alternatives we can use here. We could give require an absolute file system path. So the exact place where this thing lives on my machine, and this works. Obviously, it's very brittle. Anything could change on my machine. I could move things around. I can't share this with anybody. It's very coupled to my machine in this moment. So generally not a great idea to do this. We can change it a little bit, though, to make it a relative file system path. Now it's no longer tied to my machine. And this will work. It's a little better, but there's a gotcha. It's relative to the working directory where you've executed this program from. So in this case, if we go up to a parent directory, and so instead of just executing main.rb, we execute project/main.rb, well, now our require isn't going to work because we've actually changed our working directory. OK, so how can we reliably require this example file? What we can do, one option, is to actually add our lib directory to our load path. You know, if we're going to be requiring a lot of things from this lib directory, not a bad idea to have that lib directory in our load path. And that's exactly what this line does. It takes the path to the current file, which is main.rb, adds it to the load path, and now we can just require example and anything else that's in our lib directory. There's another way that we can modify our load path, and that's actually at runtime. If you've ever executed Ruby with this -i option, that's exactly what it does. It does what we just did, but at runtime. It's adding the lib directory to load path so that we can require things from it. And this is really useful in tests. So if we have an example test file, and within that file we want to require a test helper, something like that, it's really handy to have the test directory in our load path. But we only want the test directory in our load path when we're running tests. So that's why it's really handy to be able to, at runtime, just include the test directory in our load path. And we can run tests this way, or we could write a rake task or some other executable to do that for us. But what if we don't want to mess with the load path? What's another option to reliably require? And that's where requirerelative comes in. So if we go back and look at our example of requiring with a relative file system path, this was dependent upon the current working directory. And if we called our program from a different directory, it wouldn't work. Well, requirerelative fixes that. Requirerelative is always relative from where it's called. So if we've got it in main.rb, it's going to be relative from main.rb no matter where the program was executed from. And this would work great. Really quickly, let's talk about load. Load looks a lot like require, except for the little difference that you actually have to put the file extension on there. But the much bigger difference with load is that every time you call it, it's re-evaluating that file, which is going to be problematic if it's going to be redefining constants. And obviously, you don't want to take the time to reload things every time. This is mostly useful in like an IRB, a console kind of situation, or if you're writing your own code loading library kind of thing. In most applications, you almost never want to use load. All right, let's talk about bundler. To understand why bundler is so important, let's revisit our MiniTest example. So when we required MiniTests, they worked great. But if we look at the versions of MiniTests that I have installed on my system, I actually have two different versions of MiniTest. So which version actually got required? In this case, it's the most recent version. RubyGems is always going to require the most recent version. And if this is just a little script I wrote for myself, that's probably fine. But if I want to deploy it, if I want to share it with other people, we want to make sure that others are using the same version as well. And that's the problem that bundler solves for us. And with bundler, we create a gem file. In that gem file, we declare the gems that our program needs and the version restrictions that we care about. And when we run bundle install, it's going to make sure that we have installed versions of those gems that match those version restrictions. And it's going to create a lock file called gemfile.lock that locks our project to those exact installed versions of those gems. And now when anybody else that we share this with, or if we deploy it to another environment, runs bundle install, those exact locked versions of gems are going to be installed. And now that we've done that, we can require MiniTest, and which version is going to get required? It's actually not the version we wanted. We had locked our project to MiniTest 5.11, but we've required 5.12. And why didn't we get the locked version? Well, we're still using RubyGem's version of require, which is going to use the most recently installed version, and we still have version 5.12 installed. So if we want to make sure that we require the appropriate version, we actually need bundler's help with that as well. So we bring in bundler, we call bundler setup. What this does is it goes through that lock file, and for all of our locked gems, it's going to add those lib directories to our load path. So that when we call require after that, the MiniTest gem doesn't have to be activated and added to the load path because the correct version of MiniTest is already in our load path. So require can just go through the load path, find the right version, and we're good to go. This idea of setting up the load path and requiring, bundler can put that together for us in a single command, bundler.require. Bundler.require sets up our load path, and it requires everything that we've defined in our gem file, unless we've explicitly opted out of any of those through the require false option. So if we had put this option into our gem file, when we call bundler.require, it's going to skip over anything that's opted out, and then we would need to manually require that gem. So that's bundler. For the moment, I'm going to skip over require dependency. We'll come back to it. We're going to jump over to the lazy quadrant. Remember, when we talked about lazy, that means we're telling Ruby about a dependency, but it's not going to evaluate it yet. It's going to do it later. Let's see what that means. So in our example file, we're just defining a class and spitting out some output so we know when it's required. And if instead of requiring it, if we autoload it, when we autoload it, it's not actually going to go and read that file at all. Nothing actually happens here. Nothing happens until we reference the example constant that we passed to autoload. So we say autoload example. Example is the name of the constant that's going to trigger the loading. And then we give it a path, just like we would give to require, because in fact, autoload calls require under the hood. When we call example for the first time, that's when the requiring happens. And if we never referenced the example constant, that thing would never be loaded. So that has a few benefits. That means that our program's initially going to load faster because we're not initially loading a lot of things. We're deferring the loading to later on. And it also means that for a library, where maybe the consumers of that library aren't going to use all the pieces of it, a lot of things never have to be loaded at all. And a lot of libraries do use this. One example is rack, and I picked rack just because it has a whole bunch of them. The main rack.rb file has over 40 autoload calls just in the beginning. And of course, some of those then have their own autoload calls. So there's a lot of autoloading going on there. And notice in this rack example, we did not have to modify load path at all because it's a gem, and when the gem gets activated, the gem's lib directory gets added to the load path. So within the context of a gem, we don't have to worry about manually adding lib to the load path like we did before. So this kind of autoloading is built into Ruby. Rails autoloading is a different beast. And you'll notice that these implicit quadrants at the bottom, that's all Rails territory. Unsurprisingly, because Rails is built on the idea of convention over configuration, or I think another way of saying that is implicit over explicit. When you're building a Rails app, you don't need to actually explicitly require your application code. It's all implicit. And if we fire up a Rails console, we can see what that looks like. When we fire it up and we ask if the user constant is defined, it's not defined at first. It hasn't been loaded yet. But then if we try to use it, it gets automatically loaded, and the constant does exist at that point. The benefit is that it lets us write code like this. We can write Rails controllers and models and all this stuff without explicitly requiring any of the things that it depends on. In this case, we're relying on application controller existing, and we're relying on user existing, but we're not explicitly requiring them at all. So how does Rails go about this? Well, whenever it encounters one of those constants that hasn't been loaded yet, it's going to look in a configuration called autoload paths. Looks kind of like the global variable load path in that it is an array of file system paths. And it's going to look through those for a file that matches the name of the missing constant. And so in this case, if we're trying to reference a user constant, Rails is going to look in app controllers for user.rb. It's not there. It's going to look for app models user.rb. It's going to find it. It's going to load it. And in fact, any child directory of app is going to be part of autoload paths, and any concerns directories underneath those. Basically, anything in an app folder in a Rails app is going to be part of that autoload system. But a very important distinction is that autoload paths and load path are completely separate and distinct things. Autoload paths is used by Rails autoloading. Load path is used by require. And a good example of this is the lib app in a Rails application. It's not part of autoload. It's not in autoload paths. But we do often put things in there that we need to use in our application. And so we actually do need to require them. But Rails does add lib to load path so that we can require them without resorting to require relative or having to manually mess with load path ourselves. But what would happen if we added lib to autoload paths? Then we wouldn't have to require it like this. Is it a good idea? We're going to come back to that. Because we were just looking at Rails in development, which has this deferred, this lazy autoloading behavior. It's not going to load things until we reference a missing constant. In production, things work differently. In production, we want to take the time up front to load everything so that when users come in with requests, those are as fast as possible, and we're not loading things while the user waits for us. And the way this eager loading works is it's going to go through those autoload paths, and it's going to load every file it finds. So everything inside the app directory is going to be required when the app boots. And if we were to put something like lib in autoload paths, it would eagerly load all that stuff in production too. And lib can often become a bit of a junk drawer in a Rails application. You might have some things in there that are only needed in development or maybe even only needed in testing or whatever. So that can be a little bit dangerous. And that is why it's generally not advised to put lib in autoload paths. Leave autoload paths alone and require from lib. So now we're finally at require dependency, the thing that kind of started this whole exploration for me. Turns out that it is part of Rails. It's not part of Ruby. And it's part of the Rails autoloading system. And interestingly enough, it's to force eager loading of something that would otherwise be autoloaded. And what does that mean? Going back to this example, it makes a bit more sense if we look at the next 3 lines. So we're requiring these 3 dependencies, and then we're including those modules. Normally, we wouldn't need to do any explicit requiring, because the autoloading mechanism is going to autoload these for us, because within the active storage gem, they live in app models. And remember, everything inside of the app directories are autoloaded. So when we include this analyzable module, when active storage includes this analyzable module, if it hadn't been loaded yet, the autoloading mechanism would kick in, and it would require it, and it would be great. But what if our application had defined our own analyzable module? Not in active storage, just at a top-level analyzable module. Well, the Rails autoloading mechanism wouldn't realize that. It would say, well, we have an analyzable module, so we don't need to go autoload another one, and it would then be using the wrong analyzable module. So require dependency is a way of saying, let's make sure we go and load this thing that we know we're going to need, and not let autoloading get potentially confused. The irony is that this is actually not even necessary anymore in Rails 6. This thing that sent me down this whole path is actually no longer necessary, because in Rails 6, the autoloading mechanism has been completely rewritten, and it actually is smart enough to recognize that when we include analyzable and we're inside the active storage blob class, we're going to try to autoload an active storage blob analyzable before we use a top-level analyzable module. So in Rails 6, if you're using the new autoloading mechanism, you actually don't even need require dependency. Let's look at our takeaways from all this. We looked at requiring standard libraries. And the require method is our friend there. And even if we're within a Rails app, we still need to require standard libraries, always. We looked at requiring gems. And if it's something that you're writing just for yourself and you don't need to share it, just using require is fine. But anything that you want to be able to deploy or you want to share, that's when you definitely want to be using bundler to make sure that everybody's using the same versions. And to use that, bundler.setup along with require or bundler.require are both solid options. And it's worth noting that a lot of frameworks, Rails included, are going to do that bundler require for you. So in a Rails application, you don't need to require gems because that is happening for you. Within a project, if it's not a Rails project, we've got some options. We can use requirerelative. That'll work fine. If we're going to be requiring a lot of things from a common directory, we can add that directory to our load path and use require. Or we can use autoload, especially if we're building a library. That's super helpful. And finally, within a Rails project, embrace the implicit autoloading. Don't try to work around it. Don't try to require something that's going to be autoloaded. And don't try to autoload something that's not autoloaded by default, like lib. Explicitly require from lib. Follow that golden path, and your life will be a whole lot easier. So I hope this talk has filled a knowledge gap for some of you. I know it has for me. And I want to encourage you, when you encounter these kinds of knowledge gaps of your own, don't be afraid to dive in. Try to resist the urge to just shove it aside, and don't be embarrassed about it, because we all have knowledge gaps. If you have any questions for me, I'm Adam Logic on Twitter, or just come up and talk to me after the talk. I also have some of these YNAB shirts if you want one. Got some stickers for YNAB and Rails Autoscale. And thank you so much for being here with me today.